Hey everybody out there in whichermath land. Another quarantine edition just for the historical records. Today is Thursday, May 7th, 2020. Okay, that's just for history. Anyway, as you may have seen earlier today on my Instagram post at Mr. Witcher, I started with a big question regarding this week's lesson for 7th grade math. Yes or no to proportions and give evidence. But then I started thinking of all the different strategies from I just know it to I don't know it, so I'm going to divide, to cross multiplying, to just so many strategies. And I thought, well, that's too much for one video, so I better start with something easy and then make more videos if I need to. So I decided to use this strategy, which is to use a simple example that's easy to prove that we can all agree upon. And we're going to do that to establish an algorithm, which is a set way of doing things that's going to work with more complicated examples, and then we can trust it and use it all the time as a potential strategy. So here we go. Let's start with something simple that we can all agree on. Is that a proportion? Yes, it is. Let's change colors so we can celebrate. Proportion? Question mark? Now we're going to prove it. That's also called give evidence. There's lots of different language out there depending on what textbook or whatever teacher you might have or so forth. Support your claim. Our claim in this case is yes, this is a proportional relationship. I'm going to put a box around it so it does not get obscured or blurred. Brenda Braxton by all the other stuff we're going to add. Here's how I'm going to show lots of different ways to prove it. Number one, if I go this way, 2 times 2 is 4. And if on the other side, I go 1 times 2 equals 2, and you're like, yeah, so what? But the key here is that, which we're going to call our scale factor. Here we go back into the language. Our common multiplier. Both sides use 2 as a multiplier from top to bottom, which is evidence that these are proportions. At the same time, if I can multiply something from top to bottom, that also means if I go from the bottom to the top, 4 divided by 2 equals 2. 2 divided by 2 equals 1. That's going from bottom to top. In case that looks upside down, it's on purpose. There's that common divisor. Dividing is just a way of multiplying by a fraction. So I could just as easily say what's half of 4? Half of 4. See how I'm multiplying? Okay, so if I can find a common multiplier, that's also the common divisor going from in the opposite direction. So opposite operation. opposite direction. If you're thinking, wow, Mr. Whicher, this is very tedious, I already know all this stuff, I just want to document all the different ways you can think about proportions to prove something is either yes or no. Okay? That's all we're doing here. So I'm really teaching critical thinking. Okay, so we've got top to bottom, and now 2 times 2 is 4. There's that common multiple, that scale factor of 2 in this case. And what happens when I go from right to left? Right, opposite operation, the inverse operation. 4 divided by 2 is 2. And 2 divided by 2 is 1. So we can go, here's our strategies so far. We have left to right. We have right to left. We have top, or numerator, to bottom, denominator. And we also have bottom to top. Okay, we have inverse ops, which means if this way multiply, then go this way and divide. But we're looking for common, same ones. And since we can all agree that 1/2 is the same as 2/4, all of these common multiples and divisors of 2, in this case, prove that. Okay? Yeah, let's go ahead and do an example. Oh, another way to prove it, cross multiply. So we're going to take our 1/2 equals 2/4, which we still agree on, right? If I cross multiply, I go 2 times 2 is 4, and 1 times 4 is 4. If the two things are equal, that means they are proportional. If they're not equal, they are not proportional. That's it. Okay. Let's do a couple of examples that may not be so obvious, which you may not already know. Okay? Let's see, I have a great example right here. Give me one. Give me one. What should I use? 3/4 equals 42/58. Yes or no? So if this was a problem on a test or in a book, you would say yes or no, and you have to give evidence. Okay, let's check this out. Here's our example, and I'll do another example too. And then we'll be out of this video. It's kind of long, but the key to learn here is not to memorize all these strategies. No, the key to learn here is that we have so many different ways of proving or disproving that we need to be critical thinkers. We need to find a way to prove it. Okay? So, for example, if I want to, Let's say I wanted to go this way and see what the multiplier is, but I don't know. 3 times box equals 42. I don't know that one. So we're using our critical thinking and our example that we all agree on from above. If we didn't know this was 2, we go the other way and we divide. So I'm going to take 40. Whoa, green guy doesn't like sitting out. 42 divided by 3, which I can use the long division, I can use a calculator, whatever, but I get 14. Now I divided to get my multiplier. To get scale factor, multiplier, etc. Okay? But what that allows me to do is now I can test my 14 down here. So now that I have my multiplier, I'm going to see if it works. Does 4 times 14 equal 58? And just like up here, if the answer is yes, then the answer is yes. 4 times 10 is 40. 4 times 4 is 56. 4 times 4 is 16. When we add them, we get 56. Question, does 56 equal 58? No, but more importantly, 3/4 does not equal 42/58. Did I use the only possible strategy on this one? No, I used one. I decided I would use one because I knew it would work based on 1/2 equals 2/4. And so I got an answer of no. I could have cross multiplied, right? Does 3 times 58 equal 4 times 42? I could have done that, but I would probably need a calculator and it would be difficult. But I could go 150 plus 24, 160 and 8. And then I would ask another question. Hey, does 174 equal 168? No. So even though I have different numbers, it's a different strategy, different way to prove it that we learned up here. So many strategies, many of which I haven't even covered here, and we're already 12 minutes, 13 minutes into a video. So it's crazy. Let's do one more example. Clean slate. How about yes or no? These are just like you're going to see in books and tests. And prove it, which means cite evidence, support claim. I mean, every single video is really about the vocab. Support the claim, whatever. Okay, so this time, since I'm looking at some big numbers here, and even though I'm really good at mental math, I'm thinking I don't want to cross multiply. I want to find a common multiplier. So I start looking. Let's look with red. Oh, look at this. I know that 4 times 3 equals 12, and my proof is that 12 divided by 3 equals 4. So I know this works. And if this is going to be a yes, that means that 18 times 3 would have to equal 54. If no, then not proportion. If yes, then yes. Here's a question for you. What is 3 times 10? Yeah, 30. And what is 3 times 8? That's right, 24. When I add those together, it's 54. Our answer is yes. Even though these are still whole numbers, this works if you have decimals or fractions. And when you first look at it, you might not know if it's proportional or not, but you want to go fast, right? You don't want to spend all day like this video. And you want to have proof so you know if you're right. That's it. So this video, all I did was just give you some very basic stuff, how to test if something is proportional or not when you're given all of the values. So this is different than solving for x. This is taking something given to you and being able to prove it right or prove it wrong. Okay? That's it for this time. Stay tuned for more exciting proportions work. Boom!